Okay, these are the problems that we did in class, but I'm going to go through each one in a video just in case you forget. You have some way to reference and look back and answer similar questions. The homework will be real similar to these. Okay, so just go one at a time. Okay, constant function. And you can see, remember, here's like the general shape, and then we'll, use this blue, what's in blue, as a guide, and then we'll answer the red, whatever's in red, those questions, and then we'll graph it over here. All right, so, and then also we'll kind of compare, this is f of x equals c, that's the general form, and this is f of x equals -2. So you can see, like in this case, c is -2 for this one. Okay, so that means our first, this y-intercept, since this f of x equals -2, this is 0, comma, -2. Let me use a different color. Use black. This is 0, -2. All right, and you can see in blue it says the slope is always 0. That's just 0. All right. Graphs is red. All right, then we graph it, so we can just see the general shape is a horizontal line. And it's a horizontal line, in this case at y equals -2. So here's y equals 0, y equals 1, and y equals -2. And so just at -2, just draw a straight line. And arrows, and that's it. Okay, next one. All right, so maybe we'll answer all this first and then graph it. So x-intercept is -b over m. Okay, so we look at the general form, mx plus b, so you can see m here. In this case, m is 2 and b is 10. Okay, so -b over m is negative b over m is -10 over 2, which is -5. Okay, so the x-intercept is -5, 0. The y-intercept here, 0, b. Since b is 10, that's 0, 10. And then the slope is m, and m is 2. So slope is just 2. Okay, so we'll plot all the points. There's 2 points, the x and y-intercepts. So, whoops. So -5, 0 is right here. And then the y-intercept, 0, 10, up here. And then just draw a straight line through it, something like this. Okay, and we can kind of see that has a slope of 2. You can see, like, if you go up 2 over 1, up 2 over 1, up 2 over 1, so that's the slope. Okay, absolute value. So we know this general shape is a V. It'll be facing up or down, depending. Okay. So here we compare this. Okay, so this is the first problem so far out of this third problem that we're doing, that we have h and k. So all the rest will have h and k. And so really seeing what h and k are. What's h and what's k? Okay, h is kind of whatever is added or subtracted with x, but it's the opposite. So like when they say x minus h, it's like in this case h is 3, like a positive 3. Even though this is x minus 3, h is always the opposite of whatever number's with x. So in this case, h is positive 3. And then you can see k is plus k. This is plus 4. So k is 4. So k is the same, h is opposite. And that's for every problem from now on. You know, the other 6 problems after this. Okay, so vertex is h comma k, so 3 comma 4. Okay, we can see it's facing up, and we'll see it later on once we graph it that it's facing up. But we can see right away it's facing up because this 2 is positive. The thing outside the absolute value is positive. That'll be facing up. Okay, then we'll get 2 additional points. So we'll do h minus 1 and h plus 1 as the x values of the 2 points. Okay, since h is 3, h minus 1 is 2, and h plus 1 is 4. And then we'll plug those in. We'll just do, so a lot of these you'll have to do some amount of scratch work for. So here we can do f of 2. So just plug 2 into the function. So x minus 3, we'll do 2 minus 3, plugging in 2. Okay, 2 minus 3 is negative 1. Okay, absolute value of negative 1 is just 1. And then, so that's times 2 is just 2. You know, this is just 2 times 1 plus 4. 2 times 1 is 2, and then plus 4 is 6. Okay, so you plug in 2, you get 6. Okay, now we'll do the same thing, plug in 4. Okay, we're plugging into that function at the top. 2 times absolute value of 4 minus 3 plus 4. Okay, 4 minus 3 is a positive 1. Okay, and then the same thing as before. This is 2 just times 1 plus 4, which is 6 again. Okay, and if you do things right with this absolute value function, then these two y coordinates should always be the same. Okay, we got 3 points to plot, so the vertex is 3 comma 4. And then the 2 additional points are 2 comma 6 and 4 comma 6. Okay, and then we know that this kind of goes from the vertex, it goes in a V from the vertex. So we know it'll go out like this, and then the other way. All right, that's good. Good for that. Okay, so we'll start off quadratic next. Okay, so we can kind of compare this to this, you know, this general form to this specific problem. So we can see, just like all these, h is the number added or subtracted with x, but h is the opposite. So in this case, h will be a negative 3. And then k is a positive 5. K is always the same as the thing that's added or subtracted on the outside. Okay, so that means our vertex is negative 3 comma 5. Okay, this is real similar to the quadratic. So we can see like this, since there's a negative on the outside, this will be facing down. And then we'll get the 2 additional points by doing whatever h is. We'll do that minus 1 and that plus 1 for the x values of the additional points. So since h is negative 3, h minus 1 is negative 4, and h plus 1 is negative 2. Okay, so we'll plug those in. Okay, so I'm going to kind of do this quick. So negative 4 plus 3 is negative 1. But the negative 1 squared is a positive 1. So this is really negative 1 plus 5. All right, so this whole thing is 1, but you still have this negative out front. So just got to be careful with these negatives and positives when you're simplifying. And then negative 1 plus 5 is 4. Okay, so if you plug in negative 4, you get 4. So negative 4 comma 4 is a point. Okay, same thing, we'll plug in negative 2. Okay, same thing. Inside here is negative 2 plus 3, that's 1. 1 squared is still 1, so this is really negative 1 plus 5. So just like before, that's 4. Okay, so you plug in negative 2, you get 4. And so that's a point. Okay, so again, we have 3 points. We'll plot these and then draw the graph through it. Okay, vertex, negative 3, 5. Up there. Negative 4, 4. Negative 2, 4. Okay, and then just draw, general shape of quadratics are like U's. So you gotta know what the general shape looks like, and then just draw like these end up being skinnier usually, just like that. All right, next one. Okay, this is a cubic function. Cubic functions look like this, a little squiggly, I guess. Okay, so h and k, so we can see, just like all of them, h is the opposite of what's with x, so h is a positive 1. And since there's nothing added or subtracted on the outside, k is 0. Okay, so h comma k is 1 comma 0 for this one. Okay, so since h is 1, h minus 1 is 0, and h plus 1 is 2. Okay, we'll plug these in. Okay, so plug in 0, 0 minus 1 cubed. Okay, so 0 minus 1 is negative 1, and negative 1 cubed is negative 1. So 3 times negative 1 is negative 3. Okay, so if you plug in 0, you get negative 3. So 0, negative 3 is a point. Okay, plug in 2. Okay, so 2 minus 1 is 1. 1 cubed is 1. Whoops. So this is 3 times a positive 1, which is a positive 3. Okay, so you plug in 2, you get 3. So 2 comma 3 is a point. Okay, so we'll plot all these. What's that? Okay. So we got 3 points again. So 1 comma 0 is a point. 0, negative 3. 0, negative 3. And 2 comma 3. Okay, so if you didn't know what the general shape looked like, you might draw like a straight line through here. Might looks like, these are all in a line, but this isn't a straight line. So you got to know that the general shape looks like that. Okay, and then the point in the middle is where the squiggle should happen, I guess. All right, so just make sure it kind of curves up through the points and then curves down into the other point. Okay, and that's good enough. Okay, next one. So h is the opposite of what's with x. So -3. K is whatever's added or subtracted on the outside, so -7. Okay, so the endpoint, these are square root functions. Square roots have endpoints. So this endpoint is -3, -7. Okay, this one's a little different. So additional points, h plus 1 and h plus 4. A way to remember it, this has to do with the fact that you can take the square root of 1 and you can take the square root of 4. It's kind of the first two square roots that you can actually get without a calculator. You can't get, you don't know what square root of 2 or square root of 3 or square root of 5 is unless you have a calculator. But square root of 1 is 1, square root of 4 is 2. So that'll help you remember. Maybe. All right. So h is -3, which means h plus 1 is -2, and h plus 4 is 1. Okay, so we'll plug those in. Okay, so we look at our function over there, 4 square root x plus 3, so -2 plus 3 minus 7. Okay, so this is -2 plus 3 is 1. This is 4 times square root of 1 minus 7. Okay, square root of 1 is just 1, so this is just 4 times 1, which is 4. And then minus 7 is -3. Okay, so you plug in -2, you get -3. So -2, -3 is a point. Okay, we'll do the same thing, plug in 1. So 4 times square root 1 plus 3 minus 7. 4 times square root of 1 plus 3 is 4. Okay, so this will be 4, and then square root of 4 is 2. 4 times 2 is 8, and that's 1. Okay, so you plug in 1 and you get 1. So 1 comma 1 is a point. Okay, so we'll plot, here we have 3 points, the endpoint and the 2 additional points. We'll plot those. So -3, -7. Looks to be right there. -2, -3. And 1, 1. Okay, so we keep in mind that the square root functions look like this. Whatever the endpoint is, the graph goes from there off into the direction of the, in this case, it's going to go off into the direction of the other 2 points. And so like here, we have to know that this was our endpoint here. So the graph is going to start here and then go off in this direction. So it doesn't go, in this case, it doesn't go below, or it starts at the endpoint. It doesn't go off in any direction from the endpoint except in the direction of the other 2 points. And that's it. And so we'll just draw a line that goes through here and kind of keeps curving just like that. Okay, next one is a rational function. So rational is where you have like a fraction and the x is in the denominator. Okay, and you could think rational. Rational really has to do with ratio. Ratios are fractions. So that can help you remember. I think this is the only one that has a fraction, the only graph. Okay, but it's a fraction with the x in the bottom. Okay, so just like all these, whoops. H is whatever's with k, you know, the opposite. So, or H is, sorry, whatever's with x, whatever's added or subtracted to x, but the opposite. Okay, so here we have x minus 3. That means H is a positive 3. And then k is whatever's added on the outside. So 5. Whatever's added or subtracted. In this case, added. Okay, so now we see a vertical asymptote, x equals h. So that's for us, that's x equals 3. Okay, horizontal asymptote, y equals k. So for us, that's y equals 5. Okay, 2 additional points. Okay, so we'll do h minus 1 and h plus 1. Since h is 3, h minus 1 is 2, h plus 1 is 4. All right, we'll just plug those into the function. Just have to be careful. Okay. Okay, so plug 2 into this function up here at the right. Plug in 2 for x, plug in 4 for x. This will be 2 all over 2 minus 3 plus 5. Alright, not much room, so I'll try to squeeze this in. Okay, 2 minus 3 is negative 1. So this is 2 over negative 1 plus 5. Okay, 2 divided by negative 1 is just negative 2. And so that's 3. Okay, so you plug in 2, you get 3. So 2 comma 3 is a point. So same thing, we'll plug in 4 now into the function. So 2 all over 4 minus 3. All over 4 minus 3 is 1. Okay, 2 divided by 1 is 2. That's 7. Okay, you plug in 4, you get 7. So 4 comma 7 is a point. Okay, so we have to graph the horizontal and vertical asymptotes. If there's an asymptote, I'm going to graph that first, always. Or it doesn't matter. You can graph the points and the asymptotes in any order. Yeah, okay. So x equals 3. Okay, keep in mind vertical asymptotes. You know, vertical is up and down. So vertical asymptotes will go up and down. This one at x equals 3. So this is the x-axis, right? So go x 1, 2, 3, and then draw a line, vertical line there. And these are always dashed lines. Just go up and down. Wait, was it negative 3? Oh no, 3. Yeah. Okay, yeah. And then the horizontal asymptote is y equals 5. Okay, so this is y equals 0, y equals 1, y equals 2, 3, 4, 5. So at y equals 5, draw a horizontal line. You can think horizontals left and right, like the horizon. One way to remember. All right. And then now we can plot our points. 2 comma 3 and 4 comma 7. 2 comma 3, 4 comma 7. Okay, and then now we just have to know what the general shape looks like. So the graphs look like this. So you can see, like, in the asymptote, it like follows the asymptotes, you know, up and like one of the, you know, It's almost like the asymptotes make these four different kind of regions, and the graph will go like in one of the regions, follow the asymptote, each asymptote in each direction. And then these will always be in opposites. So if there's like a graph in the top right, there'll also be one in the bottom left. Like on this other one, if there's one in the top left, there'll be one in the bottom right. So these will always be diagonal. Oops. Okay. So now we know the graph is in the top right since we have a point in the top right. So it's got to go from that point and then the other direction. And these graphs always follow asymptotes to infinity or negative infinity. It's kind of what an asymptote is, or it is what an asymptote is. Asymptote is an imaginary line that the graph follows to infinity or negative infinity. Graph will get closer and closer to the asymptote but never touch it. All right, next one. Okay, these are exponential functions. Exponential functions we did in the last chapter, just where the x is in the variable. I mean the variable's in the exponent. Okay, so first thing, h and k. For this one here, I'm going to put this up here. So h is 0 and k is -1. Okay, h is 0 because there's nothing added or subtracted to x. So in that case, h is 0. Okay, and then k is whatever's added or subtracted on the outside. So k is -1. Okay, first thing, horizontal asymptote. Exponentials always have a horizontal asymptote, and it's y equals k. So this is y equals -1. Okay, the turning point is h, which is 0, comma a plus k. And so in this case, here I should write that down. You can see in the general form, a is whatever's kind of multiplied by the exponential part, so that's 3. I'll write that down also, a is 3. Okay, so that means that if you add a and k, -1 and 2 and 3, that's 2. So 0, comma 2 is our turning point. And then the additional points, we'll do h plus 1 and h plus 2. So h plus 1 is 1, h plus 2 is 2, since h is 0. And we'll plug those in. Okay, plug in 1. We get 3 times 2 to the 1 minus 1. Okay, just have to be careful. You always do the number to the exponent, always evaluate that first. So 2 to the 1 is 2. This is 3 times 2 minus 1. And then you'll always do this multiplication next. Okay, remember PEMDAS? You always do exponents before you do multiplication. And you do multiplication before you do subtraction. So you wouldn't do 2 minus 1. You have to do this multiplication first. So that's 6 minus 1, and that's 5. Okay, plug in 1, you get 5. So 1 comma 5 is a point. Okay, now we'll plug in 2, so it'll be 3 times 2 to the 2. Okay, remember, do the number to the exponent first, so that 2 to the 2 is 4. 2 squared is 4. Okay, then you have to do multiplication next. That's 12. That's 11. Okay, plug in 2, you get 11, so 2 comma 11 is a point. Alright, so the horizontal asymptote's at -1. Y equals -1. So -1, draw a horizontal line. Okay, and then we do the, we got 3 points. So the turning point is 0, 2. Okay, 1, 5 is an additional point, and 2, 11. Okay, and then we see the general shape. This is going to be, for us, it's going to be look like that. So you can see from the turning point, it'll go follow the asymptote one way and then go up really quickly the other way. That's what it'll do for us here. Okay, from this turning point here, it'll go up really quickly one way towards the points, through the points, and then it'll go down really quickly to follow the asymptote. Okay, and then we don't need this. Okay, so last one, logs. Okay, log function looks like this. Has a vertical asymptote and a turning point. Okay, so in this case, h is -4, opposite of what's with x. So here I'll write this out. H is -4. K is -3. And then A, you can see in the general form, A is whatever's multiplied by the log. In this case, it's 2. Okay, but we don't really need that. We really need B, sorry. B, you can see in the general form, B is whatever the base of the log is. So in this case, B is 3. And then that we'll need. Okay, turning point, h plus 1, k. Since h is -4, h plus 1 is -3. And then k is -3. Okay, to find the 2 additional points, we'll do h plus b. Okay. So in this case, it's -4 plus 3. So that's -1. And then we'll do h plus b squared. So h is -4, b squared is 9. So -4 plus 9 is 5. Okay, and all we did was just do h plus b to get -1 and h plus b squared to get 5. Okay, now we'll plug those in. Okay, so plug in -1, we get 2 times log base 3, -1 plus 4. Okay, so this is log base 3, -1 plus 4 is 3. Okay, and log base 3 of 3, remember how to evaluate. You think 3 to the what power equals 3. So 3 to the 1 power equals 3. So that's just 1. So this is 2 times 1. And 2 times 1 is 2, minus 3 is -1. Okay, so we plugged in -1, we got -3. Okay, and then actually let me erase this, put this down. Okay, now we'll plug in 5. Okay, so we'll plug it into that function at the top right. So 2 log base 3 of 5 plus 4 minus 3. 2 log base 3. 5 plus 4 is 9. Okay, and then we'll evaluate the log. So log base 3 of 9 is 2 because 3 to the 2 equals 9. That's 2 times 2. And then 2 times 2 is 4, minus 3 is 1. That's a minus. Okay. Wait, what did I do? Oh, I made a mistake in the previous one here. Sorry, up here. 2 times 1 is 2, minus 3 is this should be a negative 1. And I'll fix it up here also. Okay, negative 1. Okay, and then and then now when we plug in 5, we get 1, positive 1. So 5 comma 1 is a point. All right, so let's do all this stuff. Okay, so I'll do the asymptotes, or the asymptote first. So x equals negative 4. So negative 4, this is a vertical asymptote, so this will go up and down. Okay, we got 3 points to plot. So the turning point's negative 3, negative 3. Additional point, negative 1, negative 1. And 5 comma 1. All right, and then we look at the general shape. For us, it'll look like this. And so now we know. Here's the turning point here. So from there, it'll go to the right really slowly, go up slowly, but to the right really fast, actually. And then to the left, it'll go left really slowly, but it will go down really quickly towards the asymptote. And that's it. Oops. All right, and that's everything. Okay, so you'll have a real similar assignment to do, just filling in everything. And basically, you just have to make sure everything in red is filled out on the left, and then everything is graphed just like I graphed it in this video. Okay, if you have any questions, remember just email. And when you email questions, try to be as kind of specific as possible and try to explain your question as best as possible. I know it'll be hard through email, but just kind of really try your best. And then I'll figure out some way. I'll either explain it just in an email or in Shobi or something, or I'll maybe write up something in Notability and send it as a screenshot or something and post that in Shobi, or email it to you, or whatever works. Maybe I can also make little short videos of just answering your questions. So just let me know.